And this is Arnold Kaplan went at the perinatal stem cell conference. He threw out, well, dead cell or live cell, they still have healing.
Exosomes
Yeah,
and
there's
growth factors, etc.
Yeah.
Absolutely.
So
And
what do you
I
think?
agree with that. So if I were a doctor in today's marketplace and I were looking for the best product, I would want to look at density of the product, and you could do that with a simple microscope image. Just look at density. Make sure you understand and trust whoever's talking to you about it, the source, that they have actually sourced it from X, Y, and Z, so you're not wondering where they got the cells. And then look at the density of the product, because almost everything in the marketplace today is dead. It's all dead. Centeno was right about that one single thing. and so
the professional blogger, is that who you're referring to?
The guy that's protecting his industry through fear, uncertainty, and doubt. So the rather dishonest journalism, in my opinion. So we wouldn't even kind of call it journalism, but the he's right about that. So they're all dead. And the challenge here is that they're dead going in, and if they're not dead going in, they're dead as soon as you thaw them out.
Yep.
And that's been the understanding and what we've observed here in our lab with testing other companies' products. The cells are dead or dying. And so I've actually loaded up a slide before, case in point, where, and I have, control slides where this is not observed, but when I load up a slide post-op of a competitor product, there may be 3% living cells. But if you count again in 30 seconds, they're all dead.
They're gone. Okay.
They're gone. They're dying that fast, is kind of what I'm saying. So, and that's a challenge. But we've been able to, in-house, in our R&D lab, I have to say, because we're not doing any sort of cell expansion here, we've been able to actually expand the cells in the refrigerator with the different techniques that we've developed over the last 2-3 years to actually take the cells from an apoptotic state, a very disrupted state, an unhappy state, post morcellization, flowability, and turn them into something that's stable, that's now either growing or remaining static.
Great.
And so that's unique, and so far we haven't found anybody that's done that.
And so as far as, when a cell's undergoing apoptosis, they influence all the cells
That's
around
correct.
them. And so
apoptosis is like, it's like a stack of firecrackers. First, you already started the first wave of death by taking these cells and mechanically taking them apart from each other so that they flow through a needle, which is the end goal. The next thing that happens is those cells that you've killed signal the neighboring cells to undergo apoptosis. And that apoptosis is then, of course, has another cascading effect. So it's like lighting, a whole stack of firecrackers.
they all just start going off.
They set the other ones off.
And so how have you stopped the apoptosis so that when we thaw out the tissue once it arrives at our clinics,
right,
so that it's not like a bunch of fireworks going off all at once?
Yes, exactly. So it's a great question, and I would love to be able to answer it in detail. But if I were to have answered that in detail 2 years ago, these various other folks who've come in to my lab,
got it, yeah,
walked in and out the door, would be doing the same thing, but it would be in a way that wouldn't be good for the marketplace.
Okay.
I say we keep pushing the science forward. I think our lab's going to grow. We're going to have more scientists here, and it'll be a better sort of collaboration and growth. And I hope eventually to be able to talk to some of the leaders in this space and try to share ideas and see where we can go next. But in the meantime, we have a lot of snake oil salesmen that are rather dangerous. You don't want to give them a recipe for temporary success.
Understand.
So we're pretty careful, but what we do is non-invasive. We're not adding molecules that are outside of the simple, minimally manipulated. We're not doing anything to activate or trigger the cells. But there are some things that happen between morcellization and freeze that are simple and straightforward and very scalable, actually, surprisingly. And we never would have guessed, 3 years ago when I was making some of these things in different ways, never would have supposed that we would be able to actually improve on the front of scalability at the same time that we're actually improving the end result of viable living intact. So it's more than just the cells, too.
Oh, yeah.
You've got the cells, but there's some proteins in here that are rather complex. Like there's a 370 kilodalton protein, if I remember the size correctly, a lot of tertiary structure that is a linchpin in mental health and brain aging that may have significant impact on things like Alzheimer's. And that particular protein is not going to survive freezing and thawing if not done correctly. Those proteins break down too. It's not just the cells. And so even if you killed all the cells in the process, but you were able to preserve all the proteins, I mean, that's a whole different front that we're talking about.
Because the proteins, they could become denatured in the
Exactly
freezing
correct.
and thawing process.
Yeah,
and
if you use enzymes, you're going to tear the proteins, or you're going to digest them. Just like, it's like the same thing.
It's like food.
It's exactly food. You're not going to get the benefit of the enzymes of the food. Your digestive system is going to break it down. So the proteins get broken down potentially if you use any detergents like sodium deldecyl sulfate or SDS or whatever thing you might use to break these things apart. You're going to destroy the tertiary structure of the protein, which is really where all of its efficacy ends up anyway, unless it's a very short peptide. Those proteins, the tertiary structure is everything. And the folding that takes place of those proteins is not something that happens when you remove the detergent and just let it sit in a tube. The reality is a lot of proteins are actually mechanically folded by other proteins and machinery inside of our cells. It's absolutely complex, just like the opposite of Occam's razor. So and I know I've said that too many times, but the reality is that the manufacturing of particular enzymes and machines, proteins that are acting like machines, is something that is a multi-step process and requires absolutely perfect biological conditions. You could actually be too hot or too cold